With elimination, what we want to do is we want to write each equation in standard form. And really, when we say that, what I really mean is standard form in quotations. I want it close to standard form because essentially what I need is for my x values, my y values, my equal, and my constant values all to line up. All right? And if I used another format like y equals mx plus b, well, then it would be silly to do elimination because substitution would be such an easy option. All right? So we kind of want it in standard form. We don't have to worry about some of the specifics on standard form, like not having fractions or not having a negative a value or not having a common factor between the three values. We don't particularly care about that. What we care about is the order, x, y equals constant, okay? Because we need everything to line up. Then what we're going to do is we're going to multiply the equations so that the coefficients of one of our variables become additive inverses. And that word additive inverses essentially means two numbers that when added together equal 0. So like -5 and +5, or -3 and +3, or +10 and -10, or +7 and -7, all right? Values that when added together give me negatives. So we're either going to multiply one or both equations by something so that we get those kind of values in front of either x or y. So I need additive inverses in front of my x or in front of my y. All right. Once I have additive inverses, I just add the two equations together, and this is why we needed everything lined up. I add the x to the x, the y to the y, the constant to the constant, and I just solve whatever's left after I add those equations together. Okay. For example, if I look at this first one, I have to decide: do I want to get additive inverses in front of the x, or do I want to get additive inverses in front of the y? I have to pick a variable to get additive inverses in front of. And the obvious choice here is the y values. And the reason for that, when we look at the values here, this is actually a 1. So I have a -1 in front of one of the y values. I have a +1 in front of the other y values. Those are additive inverses. So I already have step 2 done. These are additive inverses. So I go right to adding these together. All right. And so that's why I want to look at this and I try to choose what's best. So here I'm going to add these together. When I add them together, I end up with a 5x. Here the y's eliminate. They give me a 0. That's why it's called elimination. Over here, 2 plus 8 gives me a 10. And now I solve the equation that's left is 5x equals 10. I divide each side by the 5. And I find out that x equals 2. So now from here, I just have to plug this thing back into my equation. It doesn't matter which one I plug it into, whichever one looks easiest to you. I'm going to plug it into this second one. So I do 2 times x, which is the 2, plus y equals 8. And now I just have to simplify this and solve. That's going to give me a 4 plus y equals 8. And now from here I have to subtract the 4 from each side. And I find out that y equals 4. So I get this ordered pair. Again, I can express as an ordered pair, 2, 4. And that's it. All right. If I look at the next one, I have to decide which variable I want to get additive inverses in front of. Really here, it's not that obvious. You could get additive inverse in front of x or y. It doesn't matter. For our purposes, we'll get in front of y this time. And the only reason I'm choosing y is because I've got one that's positive and one that's negative already. Okay, so I don't have to worry as much about the sign. So the first one, and this is kind of like getting common denominators. This guy has a y value of -1, the other one is a 4. So it's like getting common denominators. I'm looking for the least common multiple, which between a 1 and a 4 is a 4, so I have to multiply the first equation by 4, and the second equation essentially by 1, which means I don't have to change anything. So this first equation becomes an 8x minus 4y equals 28. And as I look at this, I've got a positive 4 and a negative 4. If I happen to multiply these and I get a positive 4 and a positive 4 in front of my y values instead of additive inverses, all I have to do is multiply one of the equations by -1 to make them opposites. And that's really what I want so that I can add these together. Okay? I can subtract equations, but we tend to make sign errors when we do that. So I would stick to getting additive inverses so that you're always adding for that consistency. And now I add straight down a 1x plus 8x is a 9x. The y values eliminate one another, and then 17 plus the 28 gives me a 45. And then from here I'm going to solve this. I divide each side by the 9, and I find out that x equals 5. But I'm not done yet. I have to plug this into one of my equations. I'm going to choose the first equation. I could have used, the second equation. I've got the first equation, the second equation, or even this third equation that I've created. But the second one seems to be the best option here. So I'm going to plug it into the second one. So I plug the 5 in for x, and I'm going to be solving for y. And so from here, I just have to subtract the 5 from each side. So I end up with 4y equals 12. and then I divide by the 4. So I find out that y equals 3, and that's it. I've got my answer here, the 5, 3, and I'm done. All right? If I look at the next one's a little bit tricky. I want to decide, do I want additive inverses in front of x or in front of y? And really, neither of these are great options this time, so I'm going to go with the x only because it's got smaller numbers here. So again, when I look at this, it's almost like getting common denominators. I'm looking for the least common multiple between 2 and 3, and the least common multiple here is 6. So in order to turn that first equation, that first value into a 6, I have to multiply it by 2. So I multiply that entire first equation by 2. The second equation, if I want to turn that 3 into a 6, I have to multiply it, I have to multiply that first equation by 3. Let me try that again. And I have to multiply the second equation by 2. Okay, so again, it's very similar to what we do when we're getting common denominators. But now, when I look at this, I'm going to get a positive 6 in the numerator, I'm going to get a positive 6 in the denominator. In order to tweak this just a little bit, I just have to make one of these a negative 6. So in other words, I have to multiply one of these by a negative, and I'm going to choose the 2. So I'm going to make the 2 a negative when I multiply. That 2 over here got a little bit ugly, so I'm going to just rewrite it a little bit. And so now the result is this first equation becomes a 6x plus 15y equals 3. The second equation becomes a negative 6x minus 14y equals a negative 4. So what happens here is I get that positive and negative like I wanted, and now I add these together. All right? So I add them up. That's going to give me a 1y, or just y, equals a negative 1. And now from here, I've got to plug this into one of the equations. I'm going to plug it into the first equation. That seems like the easiest one to plug it into. So I do the 2x plus 5 times y, which is the negative 1, equals 1. And now I have to solve. That's minus 5. I have to add the 5 to each side. So I find out that 2x equals a 6. And then from here, I just have to divide each side by the 2. And I find out that x equals 3. Okay, so I get this ordered pair, 3, negative 1. It's just a nice way to express my answer. All right? In this last one, I just have to get additive inverse in front of one of these, and as I look at this, neither one looks like a great option right now, just because I'm dealing with a fraction again. So the first thing I'm going to do, even if it takes an extra step, I'm going to get rid of the fraction. So I'm going to multiply this second equation by 2, just so I can get rid of that fraction. And so what happens is my first equation doesn't change, the y plus 2x equals 8 doesn't change. That second equation now becomes a negative y minus 2x equals a negative 8, which actually works out really, really well for us because now I automatically have additive inverses. Now that won't happen every time, but it's always good to get rid of the fraction and then see what you're dealing with. So now I have additive inverses already, so I'm going to add these up. Make sure these don't get mixed up. When I add these up, over here the y's cancel out, but the x's also cancel out, so I'm left with nothing. I'm left with 0. Over here, 8 plus a negative 8 is also 0. So I get 0 equals 0, which is a true statement. Well, unlike when I get a false statement, I know it's no solution. But when I get a true statement, this is a situation where I have infinitely many solutions. So I'm going to say infinite. There's an infinite number of solutions here. And keep in mind, I don't just say all real numbers because that implies any values that I want for x and any values I want for y. I say there's an infinite number of solutions. In other words, there's an infinite number of very specific ordered pairs that will work for this one. Because what I had really was the same equation twice. Okay? So any ordered pair that works for one also works for the other. So I have an infinite number of solutions. Okay?